Okay, when solving inequalities, you must change the inequality sign when? Multiplying or dividing by a negative, and that negative sign is the one that's with the variable, not just with a random number. And then changing the variable from one side to the other. In other words, x is less than 3 is the same as 3 is greater than x. Okay, you solve an inequality the same way you would an equation. Whatever you would do with an equation, pretend that says equals, and you just do the same thing. So when I solve negative 3x minus 4 is greater than 8, I move it. I move the 4 first, just like I would any two-step equation, and I have negative 3x is greater than 12. The difference is when I divide by this negative 3 with an inequality, and I get negative 4, I have to change that inequality sign around. And here is why. If you look, and I write 3 is greater than 2, and okay, if I have this here, negative 3 is less than 2, let's say that, and I divide by negative 1 on both sides, I'll end up with 3 and negative 2. So let me say that again. If I divide by negative 1 on both sides, like here, or divide by negative 3 on both sides, whatever it may be. If I divide by negative, 3 is not less than negative 2. That's not correct. 3 is greater than negative 2. That's why we must flip that inequality sign, because our statement still has to be true. So when we divide by negative, we have to flip the inequality sign, because if we don't, the statement is no longer true anymore. The same is true here when we are changing the variable from one side to the other. 3 is greater than 2 is a true statement. And when I flip it and I put 2 over here and 3 over here, 2 is not greater than 3. So I have to flip the inequality sign. That's why we flip them. Let's go to this next example. Negative 17 is greater than 15 minus 2. You add 2 to both sides. You get negative 15 is greater than 5x. You divide by 5 on both sides. Now I'm not dividing by negative, so I don't flip right here. Negative 3 is greater than x. But now, if I want to graph this, which I do want to graph it, if I want to graph this inequality, then it's easier to know which way to shade my line, to come back and shade my line, if my variable's on the left. So I'm going to flip this around, put my variable on the left, put negative 3 on the right, and when I do that, I have to flip my inequality sign. So this here, and I forgot to mention it with this problem, but x is less than negative 4, less than is an open circle, you shade this way, you shade the way that your arrow is pointing, and then if I were to write it in interval notation, negative infinity is this way, and negative 4 ends it this way, and that's where that comes from. And then this one here, negative infinity is this way, negative 3 ends it on this side. All right, let's go back and let's pick up these two examples. We're going to go through and solve those the same as always. Subtract 4, then we end up with x over 7 is equal to negative 1. Multiply by 7, because the opposite of dividing by 7 is to multiply. You end up with negative 7 is greater than x. You got to flip it around so that you can graph it easily. So x is less than negative 7. And here is my sketch, and it's going this way. And so negative infinity and negative 7. You put the smaller number first, the larger number last. Okay, let's go down to example number 3. We're going to distribute. We end up with 2x minus 8 here. Got to pull the 2x to the left. That gives me negative x plus 3 is less than or equal to negative 8. Going to subtract 3 from both sides. That gives me negative 11. X is less than or equal to negative x is less than or equal to negative 11. I don't want negative x. I want positive. So I divide by negative 1, divide by negative 1, and of course I have to flip the inequality sign. Now when I graphed that one, notice that the others that I graphed had open circles. That's because there was no equal to sign. This one has an equal to sign up under it, so it is a closed circle, and I graph the way that the inequality sign is pointing this way. Now, because it's closed, I don't have a parentheses like I did on all my others. I have a bracket. You see a bracket here. It's starting at 11 and going to positive infinity. Infinities always get parentheses. You always write interval notation as small number to big number. You have a closed circle with less than or equal to, greater than, equal to, and a bracket. You have an open circle and parentheses with less than or greater than. That's because it's not part of the solution. A bracket means it is part of the solution. Parentheses means it is not. And when you do infinity and negative infinity, you need parentheses. Okay, I do believe that is it. We'll go over this one. It's just decimals. So I did minus 1.2 first. That gives me negative 7x minus 2.5. I pull, now I'm going to pull 7x to the left. That's going to give me 10x is less than negative 2.5. Divide by 10. That just makes this negative 0.25. And so here's negative 0.25. There's no equal to sign. It's an open circle shaded to the left when I write my inequality or my interval notation. Negative infinity here, negative 0.25 here, and it's got a parenthesis because it's an open circle.